Okay, folks, if I can just have your attention this way for a little minute. We're going to have a bit of a yak about the M&M's project and where it might be at. Okay. If this can write properly. So a few little hints, I guess, about the M&M's project. Most of you by now would have calculated the volume of one M&M. And hopefully you've now calculated the volume of a packet. Okay, hopefully you've done that as well. Now, the interesting part of the letterbox issue that I just spoke about, the interesting thing about the letterbox one is up until now, you've been given a shape. It may have been a rectangular prism, let's just say that. You've been given a shape and you have been asked with that shape to calculate its volume. Alright, you've been asked to calculate its volume given certain measurements. Okay? Might be given that measurement, and that measurement. Yeah? Alright, and that's been okay. The interesting thing about this M&M's project, of course, is that you're actually given the volume and you've got to create the measurements. I can see some nods, I can see some smirks, I can see some, oh yeah, light bulb moments. You know, because in the past, if we just, let's just say this was 12, this was 15, and this was 24. Provided that was there, you would be required to do the area of the cross-section multiplied by the length. Yeah? So volume equals length times width, which is the area of a rectangle formula, of course, times by, let's just call that D, the depth. So we went past, we did 12 times 15. Okay, we do that first. Someone do that, please. And then times 24. So we got something like that, which would then give us the volume. How we go? Thanks, Emily or Brooke.
108.
108 for 12 times 15?
180.
180.
That's what I said.
Yeah. Times by 24? 4,320. Let's just say they were all centimetres. And so what you got were, the volume was 4,320 cubic centimetres, yeah? Okay. So we're all right with that, Damo?
Yeah.
Essentially what we were saying was 4,320 equals length times width times depth. Weren't we? We've got to get all of this to add up to that. For example, Paris, have you calculated the volume of the entire packet of M&M's yet?
No, I forgot to do that.
Isaac, have you done that yet?
Yeah.
Yeah, what did you get for that, just as a ball?
Packet.
Yeah.
I don't know which one that is.
Someone else that has, that's all right. Rothy, have you done that?
Yeah, there it is. We've done it.
Ben?
450.84 centimetres cubed.
450.84, so let's go 451 cubic centimetres.
45 centimetres cubed.
Yep, let's go with that. We've got our total. What we have to find are the measurements for the shape. Okay? Now, if you were to do a cylinder, maybe, of course, a cylinder we know. Liam, what's the surface area formula for a cylinder? Or volume for a cylinder, I should say.
No.
You might not even be there yet, actually.
No.
Emily? What's the volume formula? It should be just area of the cross-section times by the height, yeah? 2 pi r squared times by the height. So that should give us the volume of this shape, shouldn't it? So if you were to do a cylinder, what you're saying is 451 cubic centimetres should equal 2 pi r squared h. Yeah? Now, it's not 2 because there's only 1, isn't there? That's right. Thank you. Now, the curious thing with this is that you won't know, it will be difficult to work out both the R and the H. And so what I spoke to Will about yesterday was suggesting that, you know, you wouldn't expect to have a 30 centimetre packet in your pocket. All right, so what I suggested to Will yesterday is you might cut it out at 10 centimetres. You might say that is, as a height, that's a reasonable sort of thing to fit in your pocket. So you might say, I'm going to know this. I'm going to know this is 10. Okay? Therefore, what you're doing is you're rearranging the formula just like we did with, what did we rearrange the formula with to get on its own before? Excellent, Pythagoras' theorem. Remember we did that? We moved everything so that we got B on its own, or A on its own, or C on its own. Remember we did that? Does everyone remember that? Yep. So you're doing the same process here so that you get R on its own. Therefore, you'll have your measurements of your radius, and your height, we know, will be 10 centimetres. Doing it this way, folks, will get you far greater results than doing it by trial and error, or just creating a shape. You're going to have to show the calculations, okay? So where have we been so far? You should have calculated the volume of one, you should have calculated the volume of all. Therefore, the volume of all, your shape needs to be worked out in terms of its dimensions so that you can create it, so that you can see whether it holds it or not. And you do this before you create your prototype because you want your prototype to fit the amount of M&Ms. Lockie, I'll hazard a guess, you just did trial and error, you cut it out, and oh yeah, that looks alright. Is that pretty much? I'm not having a go at you. I think that's a fine idea. That is one way of solving it. But you're going to get more results if you are able to solve it using this process. Okay? I can explain that better individually or in your pairs as I come around. This is also on YouTube, so have a look at this explanation again. Is there any questions, or can I explain that better for anybody? No? No one? Okay.
Trial and error, but because I can't.
Just while I've got you folks, the other thing to consider with your construction of your good copy is that you're going to have your net. So this is, say you choose a rectangular base prism. You're going to choose your net, okay? All your logos on M&Ms need to then go on there, not by sticky tape and glue. Okay, so you need to electronically create that, which you're with layers, and you're probably more versed with that than me. But you want to make one that has all the surfaces covered with all of your labels, but not by physically cutting around and pasting it on or sticky taping it on. You're doing that electronically, so it's all integrated. Does that make sense? Yes? Yes, it does take some time, or it will take some time. So what you do is you then print it off, you bring it to me and I print it off in colour, and you paste it over the cardboard, so then you fold it and go from there. Alright? Okay, so calculate the area of the volume, sorry. Yep, what are you doing now, man?
Pi r squared times h.
Pi r squared times h, okay. Why are you doing pi r squared?
Because that's the formula
For
the radius.
area of the cross section?
Yeah.
Yep, yep. Squared times h. Good.
Do I round it off or not?
Yeah, you can. $351.3.
See, I rounded it to.
Yep. Are you finished?
Yeah.
Are you finished? Why would I take marks off at the moment?
That's who is it?
Cubic centimetres. Awesome. Wicked. Well done. Thank you.
Just a chat.
Yes.
With ours, we need to have a volume, but do we find the area of a circle? But we've got an ellipse.
You're using the volume of an ellipse,
Okay.
which is what you did for your M&M. Yeah, so with the volume of an ellipse, pretty much if that's your ellipse there, all right, you use a bit of string to go from there around to there again. That's that's R1, say. You use a bit of string that goes from there around there, which is R2, and then, so this is your ellipse again. You basically find the distance from there to there, almost a radius. And that becomes R3. So that's not a round, that's just for the middle element. Jason. Yep. That's fine. Yeah, that's all right. Cubic centimetres for one. For one. Okay. And we didn't have that before, did we? Okay. So talk to me about you had 4/3 times pi times R1 times R2 times R3. And so you had 4/3 times pi times 40 by 6 have you got? Okay, so that's what I'd question at this stage. You're saying it's 40 centimetres, not 40 millimetres. Yeah, and that's okay. All you're doing, theirs was in centimetres cubed, yours is in millimetres cubed. So if you go back to your volume equation there, if I just bring that up and go there and go there. If you go to here, then what you've got is 402.15 or so. 12 cubic millimetres. You can keep it at that if you want, or you'd say that's cubic millimetres divided by 10 to the power of 3. Does this make sense what I'm doing? And that is 0.40212 cubic centimetres. Okay, so that's right, and that's right, whichever. If you multiply that by 51, you get 20.50 cubic centimetres.
Oh, look, yeah, what shape are you doing?